Hello, welcome to Module 7B. This is Chapter 13, the Peripheral Nervous System. And this video we're going to talk about motor control and the different levels of motor control. So this is just a quick review to make sure our pen works. And we start here, so this would be a coronal or a frontal section of the cerebrum, and you look up here in the cerebral cortex, you find your upper motor neuron, and here's the axon of the upper motor neuron, and it travels through the midbrain, the pons, the medulla, and then it crosses over, so decussation in the medullary pyramids, and then goes down to synapse with a lower motor neuron, and then the lower motor neuron goes out to the skeletal muscles. So you generate a program. Let's say you want to drink a glass of water, you generate that program in your motor cortex, and then you initiate the program to contract the muscles that you need to contract to drink the water. So this video we're going to talk about levels of motor control, and then we have a flow chart over here and then a cartoon of where those levels exist in the brain. So if we start down here at the bottom with sensory input, so these would be sensory afferent neurons, and you can input information about sensations like taste or touch here with this blue line, and then it says this is going to be a reflex activity. So let's say you step on a tack, and that pain, that's the sensory input, it goes into the segmental level of motor control, so which is the spinal cord. And before that information, in this part of the cartoon, before that information about the pain that you stepped on a tack gets to the higher levels of motor control, and well, actually your sensory cortex, then you get this, before that can even happen, you can even think about what you just stepped on. There's a reflex activity that will allow you to take your foot away from the tack that you just stepped on. That sensory input about the tack that you stepped on can also go up here. It goes in the segmental level of motor control, and it can also go into the projection level of motor control. And then it can also go, that information will also eventually go up to the pre-command level of motor control with all these structures within these different levels. And then this cartoon shows the levels, so the segmental level of motor control, the projection level of motor control, and the pre-command level of motor control, and then the structures that are in those levels. So for example, in the segmental level, you have the spinal cord. In the projection level, you have the primary motor cortex, which is this green thing, and also the brainstem nuclei, so which are these green things within the brainstem. And then at the pre-command level, you have the cerebellum. So this is cerebellum, has to do with balance. And then basal nuclei. So remember, basal nuclei are bits of gray matter spattered within the white matter of the brain. So let's look at the pre-command level and basal nuclei. So in this flow chart, we're here looking at the pre-command level of motor control. And the pre-command level includes the structures, the cerebellum and the basal nuclei. And the pre-command level of motor control basically creates programs and issues instructions for motor control. And those are modified, the programs and the instructions that the pre-command level initiates can be modified by feedback from the environment. So if we look over here, here's the brain, and you do a frontal section through the brain, and then you look at it on face here. So if you're looking in the cerebrum and the basal nuclei, we've covered this in previous videos, but here's parts of the basal nuclei, the caudate, the putamen, and the globus pallidus. So these are nuclei in the brain, so that means they're collections of neuron cell bodies. So the basal nuclei will receive input from the entire cerebral cortex. So that's all this, remember that's the gray matter. So that's all this on the superficial aspect of the cerebrum. This is cerebral cortex. The basal nuclei will send communication to premotor and prefrontal cortices to influence your movement. So motor control is movement. The basal nuclei is important in starting and stopping movement that was initially initiated by the motor cortex. And then these diseases, Parkinson's disease, Huntington's disease, affect the basal nuclei. So we're still looking at the pre-command level, which is the highest level of motor control. The pre-command level, you have your neurons in the cerebellum and in the basal nuclei. And we just said the basal nuclei is where you precisely can start your movement, or you precisely can stop your movement. And then the basal nuclei are involved in complex activities of motor control. You coordinate movements with your posture. You block unwanted movements, so you have a nice flowing movement. So basically, the basal nuclei fine-tune all your motor movements. So the next level of motor control is the projection level, and that's where you look at the structures, the primary motor cortex, and then the nuclei that live in the brain stem. So this is the brain stem. So the projection level, if you come over here at the flow chart, it's the middle level of motor control. It involves the motor cortex, so those are the pyramidal pathways, the brainstem nuclei. So remember, the structures in the brainstem are the midbrain, pons, and medulla. And then within the midbrain, pons, and medulla, you have these nuclei. So vestibular nuclei, the red nuclei. And at the projection level, you're basically conveying instructions to the spinal cord. So you're over here with the basal nuclei and you're conveying information to the spinal cord motor neurons. And then whatever you decide to do, the brainstem nuclei, you also send that information up to higher levels of the brain. So remember, there in the motor cortex, there's upper motor neurons, and they travel down to the brainstem and to the spinal cord and connect with lower motor neurons, and then the lower motor neurons go out to the effectors. So for example, your skeletal muscle. These brainstem motor areas, so again, here's the brainstem, motor areas in the brainstem, sort of oversee the extrapyramidal system to control the reflexes and movements that you repeat often. So we're still here at the projection level of motor control, and we're looking at brainstem nuclei. So that's and the reticular formation. So the brainstem nuclei live in this purple patch. So this is in the brainstem. So basically, you have the midbrain here, the pons here, and the medulla oblongata here, all parts of the brainstem, and the nuclei that live there. So the reticular formation basically sends out impulses. That's shown via these purple arrows to the cerebral cortex, so that you can stay alert and conscious. And the brainstem nuclei filter out repetitive stimuli or weak stimuli, which includes about 99% of all the stimuli that comes into your reticular formation is weak, and it gets filtered out. Let let's see, if you have severe injury to the brainstem, that can result in unconsciousness. And then alcohol and tranquilizers inhibit the brainstem nuclei. It's also called the RAS, the reticular activating system. So now we're at the lowest level of motor control, the segmental level. So we're down here in the spinal cord. And then I've shown you this cartoon quite a bit. So this is sensory afferent information coming in, synapsing with a motor neuron an interneuron in the spinal cord, and then that interneuron synapses with a motor neuron that goes out to skeletal muscle. So at the segmental level of motor control, these lower motor neurons, so these guys in the spinal cord, can be activated or they can be inhibited. So this interneuron might activate the lower motor neuron, that's a plus sign, or it might inhibit the lower motor neuron, that would be a minus sign. And that's it for the levels of motor control. And then just a couple extra slides that I didn't really know where to put them. So innervation of the skin. These are dermatomes. I don't know if you've heard of these before, but a dermatome is just a skin segment. So one of these things that's outlined with a line and a color, that's a dermatome. It's a segment of your skin that's innervated by the cutaneous sensory branches of a single spinal nerve. So most of these dermatomes overlap. So if you destroy a single spinal nerve carrying sensory information, you won't be completely numb in that area. So this is just a more detailed view of the dermatomes of the skin. And then one last slide, innervation of joints. So this is Hilton's law. Any nerve, so here's a nerve in the cartoon, serving a muscle. So this nerve is serving this muscle that produces a movement at a joint. So this kind of looks like it's a cartoon of the elbow joint. So this muscle could be the biceps brachii. This muscle could be the triceps. So any nerve serving a muscle that produces movement at a joint will also innervate the joint and the skin over the joint. So here's the nerve that innervates the muscle. The muscle causes movement of this joint, so that nerve will also come down here and innervate the joint. And then this skin. So, and then here's the cartoon innervating the skin over the joint and the muscle. And I think that's it for this.